Hello, my name is Mohd Abugazleh. I am a PhD student in Environmental Science program. My project is to test the adsorption of catechol and hydroquinone on the surface of TiO2 and iron oxide. I would like to take a moment to thank my faculty advisor, Dr. Hashim Ali, the chair of chemistry department, Dr. William Burns, and the environmental science program director, Dr. Tanya McKay, for their assistance in this project. Here is my Create AState poster, and I will go through it later. As a result of increasing of human activities and energy-related CO2 emissions, climate is changing. And we can see that the temperature is increasing all over the world. The sea level rise, ocean warms, and there's a change in precipitation patterns and droughts. Also, there's already a scarcity in fresh water globally, where from all the water on the earth, there's almost 3% is fresh water, while 1% of this fresh water is surface water. The need for wastewater treatment is increasing to reduce the burden on fresh water. Catechol and hydroquinone are emerged from the usage of personal care products, which can be seen in household and industrial wastewater. In high concentration, these chemicals can cause severe human, animal, and environmental impacts. The first objective of my research is to investigate the adsorption characteristics of organic pollutants, which is the catechol and hydroquinone, on the surface of titanium dioxide and iron oxide in aqueous solutions. The second objective is to test the effectiveness of the titanium dioxide and iron oxide as adsorbents for these chemicals. Fourier transform infrared spectrometer was used to accomplish this project. The tested pollutants was the catechol and the hydroquinone, which we can see that both of them, they have the same formula, C6H6O2, but the change of the location of the OH bond for each of them change the properties of these chemicals. These chemicals have been used in industry and pharmaceutical, especially in personal care products. It is found that these pollutants have harmful effects on humans, environment, and animals. Titanium dioxide and iron oxide was used as adsorbents in this experiment. Both of them have many applications in industry, and they attracted scientists to the research mainly because of their large surface area. FTIR, attenuated total reflection crystal spectroscopy, can provide data that gives insight on the structure of the compounds as well as how strong the bond between the contaminants and the oxide themselves. The experiment took place when the hydroquinone or the catechol were exposed to the titanium dioxide or the iron oxide in several vials, as we can see here. And then the hydroquinone and the catechol was removed from the vials and placed on the attenuative total reflection crystal to be analyzed. The infrared spectra of catechol and hydroquinone was analyzed to see which peak was ideal for determination of adsorption kinetics on the surface of the oxides. The concentration of catechol and hydroquinone was increased, and the area under the curve was analyzed and plotted as we can see here. The slopes of the graphs were used to relate the integrated absorbance to the concentration of the catechol and hydroquinone. Through this project, we try to find the impact of pH on the adsorption capacity through finding the point of zero charge of the solution. Positive or negative charge surface of TiO2 and Fe2O3 which determined by the solution pH and their point zero charge. The geometry of catechol and hydroquinone when adsorbed on TiO2 and Fe2O3 surface were found to present positive or negative effects on the adsorption capacity and its rate, depending on the pH point zero charge. The kinetics of adsorption of catechol and hydroquinone on the oxide surface was followed as a function of time. Adsorption kinetics reveals that with 99% certainty that the adsorption of catechol and hydroquinone on TiO2 and Fe2O3 follows a pseudo-second order model with equilibrium achieved within 24 hours. This means that the kinetic model is only affected by the initial concentration of catechol and hydroquinone. After validating the best model of all adsorption isotherms, the long-mer adsorption isotherm model shows the maximum adsorption in hydroquinone, while Freundlich isotherm was best for catechol on Fe2O3. Using iron oxide, catechol and hydroquinone follow Freundlich isotherm, while using titanium dioxide, the long-mer model was the best fit for catechol and hydroquinone. This is maybe due to the position of OH bond and the nature of the ring influence the binding mode on solid surface. TiO2 is seen as a good adsorbent for catechol and hydroquinone, indicating a strong chemical binding on the surface. Blending catechol and hydroquinone is ideal to be removed by TiO2 from wastewater. Here is a few references for my research project. If you need more references, it's upon request.